Good afternoon, everybody. Thanks for joining the last session of the day. So I hope you guys have enjoyed VMworld so far. Yeah. So it's my 7th session, so my feet are a little bit sore, I'm not going to lie. I wanted to wear my flip-flops, but they wouldn't let me. So, all right, so let's get started. So standard disclaimer. In addition to that, I wanted to provide a warning before we did start, just because there are some things in here that if you start to make modifications to the Virtual Center database, you could potentially leave your Virtual Center in a state where it won't start, or you might have to do a complete reinstall to get it to work. But there are some things in here that it is safe to edit, and we'll get into a little bit more about this as we go through the presentation. Okay, so the journey to the cloud. So Virtual Center is one of the core components to the vSphere suite, and as such, IT production, business production, and the IT as a service range will all sort of have to incorporate that to bring it to fruition. So I mean, definitely one of the things that on your virtualization journey, I mean, you'll be in touch with Virtual Center for sure. So it's good to know about the architecture of the database. So taking your takeaways for today's session are that my goal was to give an understanding of how the Virtual Center database was designed, how it's architected, a little bit of information about that throughout, some information about the performance of the Virtual Center database, and finally some tips from GSS. So for my organization about how to troubleshoot Virtual Center. And there are some common problems that we see that we can easily avoid from everybody that would be seeing an issue with it. So before we begin, before I get into the agenda, what I always like to say about Virtual Center is that Virtual Center is just a management agent. So GSS, we use that to our advantage because it allows us to take Virtual Center down without affecting the uptime of the virtual machines. And so we can do troubleshooting and we can scope an issue without taking that with taking that into account. Now that being said, with the advent of vCloud Director, View, and other third-party components, vCenter is becoming more and more critical to the environment, and taking it down may not be as easy with those components in place. So connectivity to Virtual Center works in this way. You have your VPXD agent that runs, connecting to its database. You have a network in the middle. And then you have your VPXA and hostd agents, which communicate directly with the VM kernel and other components based on the version of Virtual Center that you're running. And moving forward, I'm sure you're all aware that we're getting rid of your ESX Classic server. So, in here, we just basically remove the service console. And this is the way that we now communicate. So, the agents run directly within the VM kernel. And as such, they're able to use the resources of the VM kernel rather than the resources of the service console. So each of them communicate directly with each other to do whatever operation that you would need with the Virtual Center server. Finally, Virtual Center is just a database application. So it supports MS SQL, Oracle, and DB2 databases just like any other. With the vSphere 5 release, Virtual Center Server's appliance will only support an Oracle database, unfortunately, for the initial release. The built-in database is a DB2 database because obviously MS SQL is not going to install on a Linux platform. But if we do, get rid of the connection to the database, Virtual Center will shut down. Now, obviously you know that, very common, but it's good to know the connectivity and that with the newer versions of Virtual Center, we've enabled connectivity checking. And with this connectivity checking, it won't immediately crash in the case you see a database down. What you'll actually see in the logs is you'll see it try to reconnect until it either successfully makes a connection or it times out after several minutes. Okay, so for our agenda today, we're going to get into the database architecture first. We're going to get into Virtual Center performance considerations, and then finally the troubleshooting of Virtual Center as I had mentioned. All right, so Virtual Center's database architecture. Before we actually get into the hardcore architecture of the database, I wanted to go through a couple of slides about ODBC, which many customers, this is one of the most common things that we see in support, is that people are changing a username, changing a password expires on the actual ODBC connector. And so where is that configured? So you'd use the ODBC database administrator with your classic version of Virtual Center, or with the vCenter Server appliance. As you can see, we have the configuration right on the database tab for that particular appliance. And this is actually where you do set them for the database appliance. That being said, for the actual ODBC administrator one, so the classic Virtual Center, many people don't know where the password is actually stored. And that password actually is stored in the actual registry of Windows. So therefore, if you take a look at the next slide here, the actual VC user account, this is where you're configuring it, right in the installer, not within the actual ODBC connector, which is a huge common mistake where people will just run through the connector wizard again, but won't ever see the password be changed, and then Virtual Center won't start or will crash. So where is it actually stored? It's actually stored in this registry key, and this registry key has a whole lot of other stuff for our components as well. But this database tab, it has all the different components that would be part of that ODBC connector, including an encrypted password. For the Linux server appliance, it's actually in the etc config files that you would see all that configuration, passwords again encrypted. And to actually change that password for the Linux appliance, you just go to the database tab as we previously showed. Or if the Windows appliance is still, the Windows server is still running, you would use the database tab in the advanced configuration. If it's not, you have to use the vpxd-p command to be able to change that and get Virtual Center back up and running. So just a quick troubleshooting note, if you take a look at the KB attached here, it's got full steps on how to change that for any of the versions of Virtual Center. Okay, so database structure. Let's get into the database structure a little bit. So if we're taking a look at how Virtual Center is architected, all the tables start with VPX_ for the Virtual Center process. You could see other tables in there for things like guided consolidation or update manager, depending on how you configured it and which database you pointed to when you're installing these additional components. Now, it has got more and more complex over time. So what I wanted to do, and I've done this in previous presentations, is give a comparison of the size differences. So if you take a look at Virtual Center 2.5, we've got 88 tables and 8 stored procedures. Virtual Center 4, 196 tables and 12 stored procedures. And then finally, with Virtual Center 5, with all the new functionality that's been added, we have 247 tables, 27 stored procedures. Now, some of them are legacy tables, I will admit, but they are still in there for upgrade purposes, etc., in the case you are migrating to Virtual Center. So, it just shows the number of features that we've added and changed over time. So the Virtual Center database can be split up into 3 separate broad categories of items. So you have your inventory items, so hosts and VMs, etc., and the security that's associated with them. You have performance statistics, which every entity in Virtual Center, for the most part, collects statistics for itself. And then finally, you have things like events and alarms. So you have your configuration portions of Virtual Center. And so let's go into the VPX entity table, which is the core table for Virtual Center. So the VPX entity table is the one that sort of stores the reference for all the objects. It's the one that the unique ID gets created for every object. And so with the different versions of Virtual Center, we've added different types of objects that do allow us to provide permissioning for the obviously different types of objects. So the main 2 that we didn't have in the initial releases of Virtual Center were the network and data store objects, which have been added after that. So if we're actually taking a look at an example of the VPX entity table, this is what you're going to kind of see when you look in that table. There might be one more column in some of the releases, depending on the version. However, the basis is still the same, where we have your ID being the unique ID for that particular entity, and then you have the name of whatever the entity is, followed up by what kind of entity it is, so it could be a VM, host, cluster, data store, etc., followed up by what its parent is. And the parent entity is very important because we can actually map out how an item would map to its parent, which GSS can use that in the case of failure of an HA environment or something like that, where you're looking to figure out exactly where an entity was before before failure did occur in the HA environment. So if you take a look up at the VM that is named after me, you can see that it is a VM and its parent is a data center all the way back up to where it actually locates itself in the actual inventory. So going into hosts and VMs a little bit more, all the VM and host information is stored in the VPX host and VPX VM tables respectively. And all this data is metadata for the actual entities themselves, which you all know that the VMs are actually running on the host, so we just have to keep track of any changes that will be happening to those entities on the actual host. So Virtual Center in and of itself, it only keeps track of that, and so if you make a modification outside of the actual Virtual Center server, you may not see that reflected until a host sync occurs with the host. So usually that will happen if you do a disconnect, reconnect, or occasionally during regular operation you will see that change. As for VMs, it's just the data that the VMX file shows in most cases that is there. Now, what we use that for is if you ever see an orphaned or unknown VM in Virtual Center, it's kind of hard just by looking at the inventory to see, okay, well, what was that VM? Where was it supposed to be? And if we actually take a look in the actual table for the VM, we can see the original path that was there for that particular virtual machine. You can see if maybe the storage changed, a folder changed, who knows what could have happened, but you can see and determine, and GSS uses this to be able to troubleshoot and ensure that we can get VMs back up in the case that we do see them as orphaned or deleted, etc. Now, deleting stuff from the tables directly is something that I never recommend. If we do delete something without doing a cascade to every other table that it is there, you will see a manage object not found reference. This is not something that's easily resolvable because we don't know which level you deleted the items on to begin with in most cases. So if you're trying to take a look and figure out, okay, well, what do I have to do to get this started? Well, you have to delete everything from every table that references that particular virtual machine. And with 200-something tables, it could be pretty difficult to figure out exactly which VM or which entity it was. And so what happens is when Virtual Center first starts up, it tries to look and go down cascading to figure out, okay, well, this is my VM, and this is what I'm looking to do with that VM. So it's going to be on this host, it's on this object. So if it doesn't exist, you can see a problem. So the only thing I can really say is if you have problems with VMs or problems with hosts and you can't remove them, contact support and we can help out figure the issue with the actual entity. Because the object itself, if it can't be deleted, we have to figure out why. And previously, I've seen issues with localization. I've seen issues with somebody changing a path or deleting part of an object. So it's just a matter of figuring out what's wrong with the object, and then we can fix the bug and make sure that we don't see it in the future. There should be no reason that we would ever see an object not be able to be deleted directly from the interface. Okay, so Virtual Center configuration and information. This is the third item that I had mentioned of the types of items that we have in the actual database. And so if you take a look at some of these tables here, you'll get your parameter table, which I'm going to go into an example next. But if you take a look at the alarm, schedule task, compute res, these are all tables that store the actual configuration of different portions of the environment. So obviously scheduled task is going to be your scheduled task information. So you can take a look at the configuration and the storage of those alarms directly from that particular table. One of the other really useful ones that we actually look at are the DV star tables. These tables store the configuration of your DVS, in which case sometimes if you have a problem with Virtual Center and you're deleting or moving items, the DVS config information is something that is often a challenge because it is controlled by Virtual Center. So you don't want to make sure it's corrupt. We can take a look at those tables and validate the configuration of that as well. So let's go into an example of the actual parameter table. So if we take a look at the advanced configuration tab, it does map directly to the parameters that you will see in this table. And that's the same with a lot of the different configurations that were in the other tables. You can map the task to their respective other tasks. So you can actually safe to edit this VPX parameter table, so you definitely can edit it if you would like. But keep in mind that if you do that, to make that change come into effect, you have to restart the Virtual Center service, so it will reread the table. So, I always recommend that you edit it from the GUI in the case that you can, because at least it's going to it'll be taken into effect right away. But this is just an example of the type of thing that you can see from the actual Virtual Center database and tables, depending on what you're looking to find. Okay, so authentication roles, another really important component of Virtual Center. And so we use Active Directory for that permission and configuration information. And previously to 4.1, we never did anything with the ESX side. Now, ESX 4.1 Plus, it allows you to add your actual ESX host into the Active Directory domain as well, which can simplify the administration of your actual ESX hosts. I'm not going to get a lot into that right now because we're mainly concerned with Virtual Center and how Virtual Center handles and treats permissions. So if we actually take a look at a Virtual Center permission, this is what it's defined of. You have to have an object, so whatever you're trying to permission. You have to have a role that you're going to assign it. So, what permissions do you want to give on that object? Then you have to have what you're assigning that object to. So what permission are you giving to somebody? The roles, the three different types. There's system roles, sample roles, and custom roles. So the system roles are roles that can't be changed and are always going to be there. The main one that we're going to always use is the administrator role. But read-only and no-access are roles that can be useful in certain situations as well. Your sample roles are roles that we give to just ensure that you have some sample of and be able to quickly provision a user an account to do a certain task. So, for example, virtual machine administrator. And then finally, we have custom roles. Custom roles are whatever you want to define. There's over 100 different permissions that you can assign out to do any type of thing in the Virtual Center database. Or not database, I should say, in the Virtual Center environment. So permissions are a little bit fun with Virtual Center if you don't understand the way that we do permissioning. It's not like a Microsoft world where basically if you have an administrator at that upper level, you're going to have that cascaded, unless you remove it, all the way down the inventory. So in this particular example, if you're setting a permission on a data store, but that permission needs to be set at the data center level, as you can see from the diagram, the data center level is the one that controls a lot of the different entities. So if you take a look here, you see all the data stores in this example are underneath the Burlington, which is where I come from, data center. So if you're trying to apply a permission below that at a different level of the environment, that permission is not going to take effect. And so this document that I have here, it's the 4.1 document because the 5.1 has not been released yet, but this one here, it allows you to figure out what level of permission needs to be set on so that it's applicable. And the main thing that we would see is somebody trying to do a permission on a particular VM. And you're going to need to assign a permission, for example, to create a disk, not on the level of the VM, rather on the data center, because that is where the data stores are assigned if you're taking a look through the hierarchy of Virtual Center. So here's an example of the actual VPX access table, which is the one that stores all the permissions for your Virtual Center environment. And so if you take a look at the actual IDs, the unique ID is just an ID that is a permission ID. So you create one, it's always going to be different every permission that you create. Your group and a role are the role that that particular user has been defined. And finally, the entity ID maps back to the VPX entity table to tell you what object this permission applies to. Taking a look at the role IDs will let you know what permission has been granted for that particular user. So the main ones I would usually see is -1 and also -2. Now the problem with the roles that we would have is if you assign a permission at a lower level than what the default permission is. So for example, in the example you see that the administrator has permission at the top of the hierarchy, and then on entity 252, somebody's assigned a -2, which is a read-only role for that particular user. So he's assigned administrator a read-only role, but the administrator's group still has full access. So what do you think would happen? Well, in that case, the administrator would be locked out below 252, whatever that entity ID is. Now, if this is something where you provided a group here and the administrator that you're trying to log in with is part of the group that you've given a read-only access to, that user is not going to be able to even remove the permission, even though they're administrator of the environment. And so there are often times where we see issues in support that somebody has locked out their environment completely because they've added like an administrators group to a read-only role because they're also a member of the group that they've assigned the -2 permission to, so the read-only permission. In which case, there's not really a way to get rid of that unless you have somebody that's not a part of the administrator group that you can go in and delete the permission. In these cases, we can go in here and we can change that -2 on the permission that was defined to a -1, restart Virtual Center, and then that permission is no longer going to be in place. It's going to be an administrative permission. I wouldn't delete the permission directly from the table because, obviously you don't want to run into any problems with managed objects being not available. But what this will do is it will switch the role over to administrator role, allowing you to remove that permission and apply it properly. By properly, what I mean is that we want to make sure that you're using individual groups or users for the particular users that need that. You don't want to use a global group for your IT staff, because if you're a member of that group and you're given a more restrictive level of permissions, you're going to end up seeing problems with your own account as well. So, just interesting tidbits there. It's something that we use frequently in support to get around a lot of the problems that we've seen with permissions and how they apply. Okay, so my favorite section, the performance data section, because performance data is probably the #1 ticket that we get into support. And so every object within Virtual Center collects performance data. So whether it's a data store, whether it's a VM, a host. So, you can see why it would be the one that would cause the most problems, because we're collecting data that is always going to be there. So if we take a look at how Virtual Center does performance data, the ESX or ESXi host send that data to Virtual Center. Virtual Center then sends it to the database, and then the database is scheduled with tasks which run that process the actual data and then purge after a single year. That can be changed from the advanced configuration, but it's still there. So here's the configuration for that. All that data is stored in 4 tables, the HISTAT 1 to 4 tables, as well as the sample time 1 to 4 tables in the Virtual Center database. The intervals that you saw on the last screen, they're defined by what you see in the keep for date here. So if you actually edit that, you can actually keep it for longer than a year if you edit the 1-day roll-up. And you can see the statistics level as well, which we're going to get into some problems that can occur with the statistics level simply due to the sheer amount of data that comes in with the higher statistic levels. Additionally, Microsoft and Oracle are scheduled with jobs. So if you have one of these 2 databases, the jobs will run that process this data and make sure that it doesn't blow up the system and consume all disk space because of the granularity levels that we have for the statistics. If these databases aren't used, for example, a DB2 database or the Express database that ships with it, Virtual Center will kick it off. The reason why we actually use the jobs is to ensure that we take as little load with Virtual Center to process this as possible. Okay. So 4.1, this is a little bit different than the previous slide simply due to the fact that we've actually added a caching mechanism in front of how we process data. And so the VPX temp table 0 to 2, they store that incoming performance data, and then they allow us to post-process it. And so what this does is it limits the number of deadlocks we'll see simply due to the fact that we're not accessing all the tables at the same time when we're inserting data as well as trying to read the data from the database. It also increases the speed for the transactions because you can do inserts a lot quicker between a bash transaction and a non-bash transaction. So let's take a look at the processing. So how does it all fit together? So in 2.5 and 4, we have it such that statistical data would be just directly inputted into the HISTAT 1 table. We can use this a little bit later, and I'll tell you some more information about finding how stats are being held in that particular table. So what will happen is once it's in there, the roll-up jobs will be scheduled to run and process the data from one table to the next based on the granularity level that has been set in the configuration. Now with 4.1 and 5, it's changed in the slight way that the statistical data never is inserted directly into the HISStat1 table. It's inserted into the temp tables 0 to 2, and then processed with the process temp table store procedures to ensure that we get the optimal performance of the database and the statistic processing. So how does the temp table processing work? This is very important for a little bit later on because it does explain a little bit about why we would see some of the problems we see with some of the newer versions of Virtual Center and how we can prevent that from actually having a serious impact on your environment. So the temp table processing works like this. So Virtual Center starts up, and it starts writing to the first temp table. So after 2.5 minutes, Virtual Center schedules a thread that's going to basically take a look and switch to the next temp table if it does need that. So what will happen is after 5 minutes of storing data in the temp table 0, it moves and starts inserting data into the temp table 1. And then post-processing is done on temp table 0 to take that data and insert it into HISStat1. This is why it is a caching mechanism, because what happens is it moves that data from one table to the other, which allows less locks required to the HISStat tables as processing occurs. Now this only actually happens to the HISStat1 table because that's the one that stores all that incoming data for further processing by the other roll-up jobs based on the statistics levels that have been set, etc. So it keeps going through, and just basically loops around using those 3 temp tables. The reason that we do need 3 temp tables is because what will happen is if we have processing still occurring on the previous table and we try to insert, you're going to see that it's fail because you have to have space available to be able to do that. And therefore, if we have 2 tables, you always ensure that one table should be empty when the next it loops around, or the next time it loops around. All right, so we're going to get more into that performance data stuff in the next section with performance as well as some of the troubleshooting aspects. But before we do that, let's go into the final section of the database architecture, which is your tasks and events. So tasks and events are stored indefinitely by default in any of the versions of Virtual Center. So if you take a look, you'll see the last 10 tasks and events stored on the actual tab as you're going forward. That can actually be changed, and we use that all the time actually in GSS to change it such that we can see 1,000 or 10,000 tasks, because we need to be able to see that historical record in the case where we're seeing actual problems with the Virtual Center database. So VPX task and VPX event are those 2 tables that would store the majority of the information for the tasks and events that occur. Large environments obviously will keep these tables growing and will make them grow quicker. And also poorly architected management agents can also dramatically increase the size of these tables simply due to the fact that if we log in, then log out, then log in and log out, it's going to consume 2 events every time. So we have seen issues in the past where we see that happening every second for every VM. So you're seeing an extreme load on Virtual Center due to the SDK calls, but you're also seeing a lot of tasks and event data coming in, and it's not actually telling you what's happening in your environment, rather just as somebody logged in and then somebody logged out. So let's take a look. In Virtual Center 4.x and 5, we've actually have a stored procedure that allows us to clean that data up in the case that you want to. This is disabled by default, but it's something that will dramatically help to reduce the size of your database if you have a really large environment. And so this is actually called the data retention policy. And this is where it's configured from the advanced configuration. As you can see, by default, it's not enabled, and it has 180 days as your default, but you can set that to whatever value you'd like. All right, so let's move on to performance considerations. I know this is something that's of interest to a lot of people because we want to make sure that Virtual Center is performing to adequate standards to keep the environment up and running. So it's a major cause of pain for administrators, and we always strive to improve the performance with every release. Now, if we continue to increase scalability, that also starts to impact the performance considerations on each of the different entities within Virtual Center. So the reason why we see problems with Virtual Center in most cases is because of the stored roll-up job procedures. And that's because we insert data, it's rolled up every 30 minutes, and then it's purged from that particular table. So what you would end up seeing is you'd end up seeing fragmentation of the tables, and as well as the indexes, just simply due to this particular roll-up. So the more that you have your statistics level set high, the greater impact this will have on your actual configuration and the speed of access to data in your Virtual Center environment. So there's a lot of information here, and I've had some requests for this actual information from other attendees. But this PDF shows sizing recommendations, backups, restores, has a whole bunch of information about the actual configuration of the Virtual Center database, as well as sizing for memory, statistics, etc. So there's lots of information in there. I would heavily recommend going through it for some more best practices and recommendations on database performance as well as Virtual Center performance, and even plugin performance there as well. Because Update Manager, if it's in the same database as Virtual Center, can potentially see a problem as well. So I mentioned defragmentation and fragmentation of the actual database and indexes. And the reason why this would be needed is simply due to the SysTick roll-up jobs running and taking data and moving it from one spot in the database to another spot in the database. So you can take a look at the defragmentation by running this particular command. So the showcontig command, what it's going to do is going to show the contiguous space within your actual database. So if we take a look at the actual command being run, we can see that in this particular case, we have a 27% scan density, and we also have 38% for logical standard fragmentation. So ideally, it should be a little bit different when we're taking a look at a properly running and processing database. So to actually do a defragment, we can actually do this. And then what we should see if we run that first command again is we should see this. We should see a scan density closer to 100%. As close as we could get to 100% is proper. And then finally, the logical scan fragmentation should probably be below 20% after you run a defragmentation on the actual hisstat tables. And the hisstat tables are the one that generally you're going to want to do this to, because that's the one that's changing the most frequently. Other than that, we have a reindex, which this is going to help in the case that you have a lot of entities or a high performance level set. And the reindex, what it's going to do is it's going to recreate the indexes so that they are properly using or able to search the data that's in the database. And so usually I recommend to shut down Virtual Center, but some of the newer databases, SQL 2008, they actually do support online reindexing. However, just to be safe, I always say shut down Virtual Center in the case and do that maintenance if you do see that you are seeing fragmentation there. Okay, so best practices, another thing that I find really interesting. And they're also a dime a dozen, so you have to just realize that a lot of best practices are only a best practice in larger environments, maybe small environments. So let's get into a few. And the biggest thing I can say for a best practice for Virtual Center is that make sure that you have adequate hardware and that you're not exceeding the supported maximums on the actual configuration based off of our documentation. And the reason for this is that we don't test greater configurations than this. But in most cases, every version of Virtual Center that we release includes some sort of supportability increases in terms of the number of VMs or the number of hosts that we allow in the configuration. You're going to want to make sure that you minimize the number of network hops between your Virtual Center and your ESX systems. And the reason you want to do this is because the more network hops, the longer it's going to take for you to get any of the configurations proper for each of the hosts in Virtual Center. It's going to take a lot longer. Disconnecting vSphere client sessions That's also going to help to reduce the memory footprint that Virtual Center uses. The more clients we have left open or idle, the more memory consumption the Virtual Center process is going to use, which in the past was a big thing because we didn't have a 64-bit process. In 4.1, we are for a 64-bit process for Virtual Center, so it can utilize a lot more memory as long as you have that memory available within your system. You're going to want to separate any components that are running on Virtual Center server. So if you have Update Manager, Converter, View, anything like that that you've tried to install on that system, it can take and hinder the performance of your actual Virtual Center instance simply because there's not enough processing power in the actual underlying hardware. Much like the vSphere client settings, overly aggressive alarm settings can also cause performance issues with Virtual Center. If you're triggering an alarm very, very frequently, there's a lot of processing that needs to be done to basically get Virtual Center to run and operate. Finally, this is one that I actually added this year, the sizing of the JVM heap for Tomcat. And the reason why I add it here for best practices is that Tomcat is a consumer of a lot of memory. So if you have an incredibly large environment, you have to make sure that you're sizing your Virtual Center appropriately for not only Virtual Center, but for Tomcat as well, because you'll see things like you won't be able to search, you'll see things like some of the plugins won't work, and if you actually take a look at the log files for Tomcat, what you'll end up seeing is you'll end up seeing that, hey, I'm out of memory, and that's why I can't operate. So you'll see issues with all those plugins, and most of the time, it's just due to the JVM heap. That being said, we have some bugs open right now that I've been working on to improve that, because at some point, it has to be enough. We can't continue to just use memory, because I've seen cases where we've seen 10 gigs is what's needed for Tomcat to run. Depending on a huge and large environment, you have to make sure that you have that sized appropriately. So moving to the actual database, again with the hardware requirements, but the reason for this is because most agents for SQL, whether it's Oracle, whether it's Microsoft DB2, they're going to be meant to just consume memory. So they're going to consume resources because they're there. I know with SQL, it's going to take as much memory as it can get right off the bat, unless you've limited it. So therefore, if you're going to work with that and you have a large inventory and a lot of transactions with Virtual Center, separating these two from one another, two different servers, is going to provide a pretty big performance increase unless you have adequate hardware in the actual systems. Storing the transaction logs and the database files on separate drives also will help with the performance of Virtual Center. You're going to be able to write multiple things at a time in this case, because you can write your transaction logs to one drive and you can write the actual data to the database in the other drive. High-performance RAID devices can also help here as well, depending on the type of workload and how big your environment actually is. Reindexing, we mentioned it. It's something that if you take a look and you see some fragmentation, if you have a really large environment, it definitely will help to reduce, the delay in accessing the actual data that you're looking at. So, it definitely can help. And I actually used to have a slide in this presentation for the recovery model. I took it out because I think I can discuss it pretty well here. But the recovery model for an MS SQL database is something that can consume as much space as it wants by default, unless you configured it otherwise. Most companies that are larger would have a database administrator that would be able to take care of the actual transaction logs and take care of the actual information that is stored in that. That being said, a full database recovery model, if not in check, will consume all the database because it's meant to provide point-in-time recovery for the database in the case that it does have a failure of a piece of hardware or something other than that. So that being said, if you don't have a database administrator, make sure you're backing this file up. One thing that you will hear from GSS all the time is to move it to a simple recovery model. You have to keep in mind that with this configuration, there is no transaction log in essence. There is one, but it's not something that you can use to provide point-in-time recovery from your actual database failure. So you're going to have to make sure that your RPOs and your RTOs, your recovery point and time objectives, that they're appropriate with what you're comfortable with in your environment. So if you're comfortable with having a full database backup done once a week and then having to go back to that point, then maybe it's okay to have it in a simple recovery model mode. Just make sure that you're sizing that properly, because as long as it's sized properly, you're not going to have a problem. And do your proper maintenance, and you're never going to see an issue with the actual database in regards to the transaction logs. So let's go into some Oracle-specific stuff. I've only got a couple of things here that are really specific to Oracle. I mean, sufficient memory for any database is required, and you're going to want to make sure that you follow the recommendations based off of the provider. Previous to 5, create this unique index. If it doesn't exist, you're going to see huge performance degradation with Virtual Center. Finally, setting the appropriate process and sessions parameters from within Oracle, if you have a really large environment, of course, is something that that is going to help with the speed of access and the number of connections that can come in with Virtual Center. So that's definitely something that I would recommend that you take a look into, or get your database administrator to take a look into if you're using an Oracle database. Moving on from that to the troubleshooting aspect of the presentation. First off, I'm going to get into logs because they're the most important thing, quite frankly, that we do in support, is we make sure that we have the logs so that we can take a look at the configuration and see what the problem actually is. It's very difficult to diagnose problems if you don't have proper logs or adequate logging, and as such, I provide the locations to each of the paths for each of the different versions of Virtual Center on this slide as well, just for the reference of everybody. Common log files, we've got log files for absolutely everything, so definitely helps in troubleshooting. So your vpxd.log is the one that's going to be the log that we're going to look at for everything Virtual Center. Now, if we are talking about some of the other services, such as web access or SMS or the performance overview charts, there's all different sorts of logs that we can look into for that, including the Tomcat logs, which I mentioned the out-of-memory condition, which you will see in the stderr.log of that configuration. Make sure you look in them. If you go right to the bottom, you're going to, in most cases, see the last couple of events that maybe caused your problem in there, and you can address that based off of just reviewing those very briefly. You can increase the log level right from the GUI or from the command line if you so chose to do that. The flexibility the command line provides is that you can increase the number of log files as well as the size of the log files as well. From the GUI, it's just a matter of changing the level, and if you don't have proper sizing of the number of files, you potentially just roll over and you won't be able to see anything just because of the additional logging that's been enabled and only the default log level set. Okay, here's a really important slide. This is the first thing I show to my TSEs when I train them to take calls on Virtual Center, is how do you look at a log file? The most important thing on this particular slide is the one in green, the thread ID. If you see a Virtual Center crash, for example, the first thing you're going to want to look is here, because if the event before the actual crash in the logs isn't the same thread, then that event didn't do anything to cause the actual crash. So what I do is I grep out with this particular thread ID, or whatever the thread ID may be, and you can map out and see exactly what that thread was doing before the actual crash happened. And most of the time, the last event that happened right before that with the same thread ID is going to be your culprit. So whether it's a configuration of a link, or whether it's something that was just processing, whether it's an alarm, or whether it's a host ad, who knows? But it's something that's what I use all the time. You just limit it down so you don't have to worry about the excess fluff that gets put into the logs all the time by just regular operation. Very, very important here. So, that's something that I teach directly to my TSEs as soon as they come on board. All right, so common problems for support. We've got a few things here. And so slow response and timeouts is one of the biggest things that we get reported. And the slow response basically being, you could have many different symptoms. So you don't get performance data, you see slow response on performance data, only real-time data is available. You see things like performance data is currently not available for this entity. And all of these things, ironically, are caused by, in most cases, growth of the database. So the two things are actually pretty related. And so if we're seeing excessive growth of the database, the three things that generally are your cause, SQL agent not running, agent jobs not started, so if you have migrated database, for example, what would happen is the agent jobs may not be created. And if they're not created, you're not going to process data, and you're going to see excessive growth, as well as all the other symptoms I mentioned on the last slide. Deadlocks prior to 4.x, or 4.1x, I should say, were something else that would be causing issues with performance data processing. Because if deadlocks are occurring, we're not actually processing the data, we're just sitting there waiting for a condition where we're able to actually process that. Finally, if you have logging set up to above level 2, the issue that you will see is that you have an immense amount of data coming in. So if you're not sized properly from the amount of configuration information you have in your virtual center, then you potentially will see issues because it's not going to be able to process the information coming in adequate time. Make sure that you're sizing properly if you're going to use those levels. It's not that they're not supported, but we generally only use them for debugging and support to prevent issues. Okay, so deadlocks, I mentioned a couple of things about deadlocks, but the reason why we added that caching mechanism in 4.1 and 5 is simply due to the fact that people were seeing a substantial number of deadlocks in the configuration. And the reason why we see those deadlocks is because when you're inputting information as well as trying to read information and write information is something that, we're just going to kill the roll-up. The reason why we kill the roll-up is so that we don't lose data. If we're taking a look at the actual condition, we've made it such that it doesn't actually impact the data when a deadlock occurs. It just terminates that process to ensure that we're able to actually go back and do it again. So it will run again, it's just you'll see the actual error message, which in a lot of environments you have to justify. So upgrading to 4.1 and 5 actually has resolved the majority of those issues that I've actually seen. Not seeing a whole lot of problems with deadlocks on 4.1 and above, which is good, obviously, right? Trending is going to be really important because that's what we end up doing is we trend to say, okay, well, when do you actually see the deadlocks occur? And is there something else happening at that particular time that we're seeing the deadlock on that particular table? What we can do to actually take a look at it, ironically, is just change the job by a couple of minutes, and it usually will prevent the majority of those deadlocks from actually occurring. Most people don't really think of it, but if we're inserting data at the same time as we're trying to process the data, that's when you're going to see a problem. And if you just change that, by default, you're going to be okay with the running of those actual jobs. So diagnosing, this is a really important component as well. So diagnosing the size of a table is actually pretty easy. So with MS SQL, you can run the first command, or with any of the databases, you can actually run the second command as well. And what they will provide is output similar to this if you're running SQL. You just get a row count if you run the second command. But what this shows, it shows the number of rows and the amount of data that's used in the database for these particular tables. And these are just your hisstat data. And this is where you're going to see the majority of that issue come in. So what's good and what's bad? Well, there's not really an answer that suits all situations for this one. Generally, though, if you see more than 10 million rows in the hisstat1 table, you should probably investigate into it because you might just not be seeing data being processed. So, investigate, and you can see if the jobs are failing, if they don't exist, if the scheduler's not running, and then you can validate the actual configuration of that as well. So one of the other things that we can do with Virtual Center 4x and 5 is we can actually see the last time data was processed for each of the different roll-up jobs. In this particular example, I'll leave this up for a few minutes because it's an interesting query. What will happen is it's going to tell you the last time data was processed from the hisstat1 table to the hisstat2 table. And the importance of this is that if you see a date such as the one on the actual column here, this is the last time performance data was actually processed in the database at all. Now, if the last time was, April 2009, you know that you have a problem in the database. You'll probably also consequently see that the HISSStat1 table is really large in number of rows, or that you're just seeing weird issues with performance data like mentioned in some of the previous slides. So definitely you can run this, and then you're going to have to determine, okay, well, why aren't those jobs actually running? And so, I mean, again, the agents are the ones that would be the biggest issue for this. And then also maintenance of the database and higher statistics collection levels. Those things are your most common things that we see in support in regards to what actually causes these problems. There are very few things that actually occur on the database that can't be explained by one of these things, or potentially one of the bugs. So it could be a bug that could occur that would cause growth of these tables as well. Okay, so how do we resolve it? So you can manually run the roll-up jobs. Now, the problem with manually running the roll-up jobs, you don't know if something's actually occurring or if you're going to be able to catch up. So for example, if I go back here to this slide, and I see this number, and if I see that the amount of data that's being processed over an hour or a couple hour period is less than the amount of data that's coming in over that same period, then guess what? You're never going to catch up. So either you have to put more hardware in the system to be able to do that processing, or you have to do one of the things on this thing, which is a truncate commands. The beauty of the newer versions of Virtual Center is the fact that these truncate commands can be performed on the individual tables as well. And so by just performing the truncate on the HISSStat1 table, you're going to get rid of any of the data that was coming in and wasn't processed that's causing the roll-up jobs to fail from that previous command. Now, I wouldn't recommend a truncate unless we saw that the amount of data that's able to be processed is less than the amount of data that is coming in, that type of thing. And as such, you can just quickly clear out just that data that wasn't processed and still keep the rest of your historical data. So if you only had a problem in the last month, but yet you have the previous year's worth of data, all you'll see is you'll see that data for that last month gone, and the rest of it will still be there for your viewing. Now, if you take a look, you will still see a gap, obviously, of that month, but it will dramatically help to get that data coming back in again, which is most times what you're going to be needing for your management or for sizing of your environment. So it's better to actually have the data than wait for it to process in some cases. I mean, it's all dependent on what you actually see. There's also a KB article that will help out here as well. I mean, depending on the speed of your system, it may or may not be effective. But this KB article shows a script that will allow you to delete performance data prior to a certain date, which potentially will help. But it also is something that, if you have a lot of data or not enough cycles to actually process, it could just sit there and run for days and days and days, and then you're just going to have to wait for it to actually finish. All right, so tips to avoid problems when we're seeing performance gaps. And ironically, the actual caching mechanism we put in front that is supposed to help with that can actually cause gaps from occurring if you don't have your database sized appropriately. When the roll-up jobs run, if it's not able to process those two tables before the insert tries to go to those two tables, you now have 3 tables that are waiting on processing. And as such, Virtual Center can't do anything with that data, and it ends up crashing the actual service. Or not crashing, sorry. It ends up not collecting database information from that. And so we often see cases in some of the earlier versions of 4.1 where you'll see, performance data gap, performance data gap. And the majority of those cases that I've seen are actually resolved by just increasing the amount of resources that the Virtual Center server database has in there. So therefore, it can process the data much more quickly. In addition, the actual roll-up jobs running, we just have to make sure that they're optimized to actually do that by ensuring that the performance data and the drives that are running on are able to be properly accessed in an adequate amount of time. So faster storage, more memory, that's going to help in the amount of time it's going to take to do this type of configuration. So finally, for the most common problems that GSS sees, we see disconnects from Virtual Center. And so I wanted to give a little bit of insight to you guys about why we would see a disconnect from Virtual Center. And there are two basic things that I've learned in my time. First off, you have a network problem. Network problem, obviously. It's going to disconnect the host if it loses too many heartbeats. Or an agent problem. And by an agent problem, I mean anything on the host. So if VPXA is not able to talk to Virtual Center, or host E is not able to talk to VPXA, what you will see is that it will disconnect from Virtual Center. The thing being is that you have to determine why that is if it's an agent problem. By taking a look at the logs, you can easily do this in the same way as if you're looking at the Virtual Center logs. There's a thread ID, so if you're seeing a crash, if you're seeing consumption of the resources really high on the ESX box, especially if you're using an older classic system, you will see issues with host E, because if it's not able to send its heartbeats out, then you're not going to be able to get Virtual Center heartbeats out either. And therefore, you're going to see problems with the actual configuration there as well. So that's what I have for us today. So I hope that I've given you a better understanding about the design of the Virtual Center database, about how to increase performance and troubleshoot the actual Virtual Center database, and then also how we in GSS approach troubleshooting Virtual Center and a few of the common issues we see and some resolutions to that. So I hope that that's definitely provided that information to you. And I'm going to open it up for questions here. So if you have a question, step up to the mic. Otherwise, we can chat a little bit after.
So I have a question. So typically when you configure a database for vCenter in the past, I went ahead and put it on a separate physical SQL cluster so it's highly available but separate from my virtual infrastructure. Is that considered a best practice?
We either say yes or no on that one. If that's the type of configuration you have in your environment, we're not going to say that it's not going to work. But we don't actually do any testing with Virtual Center in like an MSCS clustered type situation. So there are things like in the middle of a failover where you might see Virtual Center stop, and you just have to make sure it restarts.
Yeah, but as far as availability of the database and getting your infrastructure back up and running in case of a problem, isn't it best to have it on a physical piece of hardware?
Physical or virtual, either way. We actually recommend for Virtual Center in most cases to actually have it in a virtual machine nowadays, because for backup and recovery, it's a lot easier to back up, recover, and you can use vMotion HA on virtual machines where you can't in a physical environment.
For the SQL database, you recommend the database to be virtual?
Yep, SQL database as well as Virtual Center. That's what our engineering team actually has been recommending as of the more current releases of Virtual Center. And that's just simply because we can use all of our technologies to actually leverage on that.
Two questions. One, you mentioned JVM heap size. How do we know where's that documented at as far as what the size it should be?
Unfortunately, that isn't actually documented. So what we actually see is in the actual installer now for 5, we've actually shown that up on the actual, in the middle of the installer where you can select small, medium, and large size. Unfortunately, though, there's no way for us to do that in previous versions, so you just have to take a look. And if you're seeing problems, see if you actually are seeing issues within the log, and then what will happen is you can go in and fix it. We have a KB that we're in the middle of creating that's going to help with that, though. It is definitely something that we're aware of, and we want to make sure we do it, but there is no easy way to determine what it would be, because every environment is different. So the more we have going on with the environment, the more you're going to potentially see an issue with.
Other question I had is does 5 fix the ability to track the deletion of a large snapshot. vCenter seems to lose the tracking of the deletion of a large snapshot.
I am not sure if it actually resolves that, but I know that within 5 we actually have added information that allows you to track the consolidation status
I know that.
of that, right? So I mean, if you see a snapshot on there, it will either say, yay, I need yes, I need consolidating, or no, I don't. And if you see that, then that'll be something that will allow you to track that to some regards. I don't know if that issue that you're actually talking about is actually resolved in the release.
That would be a no.
Lot of times the indexing service fails.
Okay.
What would be a troubleshooting technique I can use to find problems with that?
What I would recommend is taking a look at the actual logs for that. Because the actual logs are what, in essence, is going to help with determining why it's actually failing. And I mean, without actually seeing those, I can't actually tell you what would be causing it. I mean, there are many different things that could. But if you do actually open up a ticket, I mean, we can actually take a look and see if we can figure out, why it's actually causing it. If it is a bug, we'll get it fixed by our engineering folks.
Okay, last question.
Sure.
For Oracle, do you have a PDF like you had for SQL?
That PDF actually has Oracle stuff in it as well. Okay. I mean, if that one doesn't, then there is another one that's specifically for Oracle.